This is part 7 in our series of lectures on section 1.6. In this lecture, we're going to look at this particular limit. The limit is x goes to 1 of x squared plus 3x, which of course is equal to 4. And first I want you to write out what it says in symbols, and then I want you to write a formal proof. So you'll have to recall what is the working definition of the limit of a function, and just simply write that down, but be very specific about the a value, the f of x value, and the L value. So put your video on pause and go ahead and do that. So here it is written out in symbols. It says, for every positive real number epsilon, there exists a real positive number delta, such that for every real number x, if the absolute value of x minus 1 lies between 0 and delta, then the absolute value of x squared plus 3x minus 4 is smaller than epsilon. So how do we prove such a thing? Well, the beginning is easy. We begin by saying, let epsilon be a given positive real number. Then the real challenge is to do this step here. We have to figure out how to choose a specific delta, depending upon that epsilon that someone just gave us, so that all the rest of this works. So essentially what's going to happen is, after we choose that delta, someone is going to give us an x. We're going to say let x be a real number. And then we're going to suppose that the absolute value of x minus 1 lies between 0 and delta. And we're going to have to try to figure out how to prove that this happens. So the next step is to calculate this and see what condition on delta is required, so that the moment we know this, then we can deduce this inequality. Okay, so let's calculate this quantity x squared plus 3x minus 4, and we'll see what's involved. So x squared plus 3x minus 4, of course in absolute value, factors as x minus 1 times x plus 4. Now we know that we're going to be assuming that absolute x minus 1 is smaller than delta. So that's certainly going to be smaller than delta times absolute x plus 4. So the next thing we need is we need to get an upper bound on this. So let's use the technique that I showed you before. We want to get the x minus 1 in the picture, so I'm going to write it as x minus 1 plus 4. That's equal to delta times x minus 1, I'm going to group those together, plus 5. And now I apply the triangle inequality to get that that's less than or equal to absolute x minus 1 plus 5. Now we know that the absolute value of x minus 1 is smaller than delta. So if I chose my delta to be less than or equal to 1, or any number, I can pick anything, but 1 is convenient. If I knew that that was less than or equal to 1, then I'd have a 1 here, and I'd get 6 delta. So the first condition that I want is, I want my delta to be less than or equal to 1. So that's something that I can arrange for. Now, I want this last quantity to be less than or equal to epsilon, and that then implies that delta is less than or equal to epsilon over 6. So that's another thing that I want. I want delta to be less than or equal to epsilon over 6. So if I have these two properties, then all of this string of inequalities will work, and I will be able to deduce that this thing is less than or equal to epsilon, or is less than epsilon. Okay, so all I have to do is choose my delta so that both of these things happen. And of course, in addition, delta should be a positive number. So one way of doing that is to just simply choose delta to be the minimum of the two numbers 1 and epsilon over 6. Because if I do that, then it will simultaneously be less than or equal to 1 and less than or equal to epsilon over 6, and it will be automatically positive. In other words, take these two numbers, and whichever one is the smaller of the two, I call that delta. So that essentially solves the problem. And so when I get to this step in the proof, where I have to choose my delta, I just simply say choose delta to be the minimum of 1 and epsilon over 6. If I do that, I should be able to make the rest of the proof work. So now maybe you're ready to write up the rest of the proof. Put your video on pause and see if you can go ahead and write all of the details of the proof. When you get to this step, just write that and see if you're not able to finish all of the remaining steps. All right, so when you come back, you can compare your solution to mine. Okay, here you see my proof. And as I read my proof, follow this here from left to right and see if I'm doing what I said I was going to do. First sentence should be, let epsilon be a given positive real number. Here, I have to now choose my delta, and remember I said choose delta to be the minimum of epsilon over 6 and 1. Then, let x be a given real number. Let x be a real number. We're doing a direct proof, so we say suppose this happens. Suppose we have that. Then, and now I have to prove that this happens. So I will not write this out again. I will merely start on the left side, and I will prove to you that I can force that to be less than epsilon. So I say then, absolute x squared plus 3x minus 4 is equal to this. I've just factored. It's less than delta times x plus 4. I've just used the fact that absolute x minus 1 is smaller than delta. Now I'm just doing a little manipulation. I'm adding and subtracting 1. And then I'm applying triangle inequality to the resulting expression of x minus 1 plus 5. See, I've done triangle inequality here. And now I know that absolute x minus 1 is smaller than delta, which is itself less than or equal to 1. So I get to replace this by, I get to say that this is less than or equal to 1 plus 5. So I get 6 delta as an upper bound. And 6 delta is itself less than or equal to epsilon, again because of this fact that delta is less than or equal to epsilon over 6. And so I've completed the proof because I've shown you that I was able to deduce this fact, right? I've got that this is less than or equal to epsilon.